Alright, let's talk a bit about spanning tree in this video. We're going to start off with the show spanning tree command. The first thing I'm going to point out to you is how to tell what switch is the root. Now in this topology we have two switches only running VLAN 1. We're just going to keep it simple. So right here, as you can see, it says root ID. This is all the information for the root switch. Now if you notice, for your MAC address, it differs from the switch that we're on right now. So that's going to tell us that the switch we're on right now is not the root bridge. Let's hop over to switch 2. As you can see, the root ID, the MAC address, it matches the bridge ID. We also have a big statement right here that says this bridge is the root. So if you ever need to know if you are on the root switch or not, run the show spanning tree command, look under root ID, check the MAC address, check the MAC address of the switch that you're on, and also check for that statement that says this bridge is the root. Another way we can tell that this switch is not the root right away is because it has a root port. Root bridges do not have root ports. As you can see, if we jump over to switch 2 here, all the ports on the root bridge are going to have a designated role. Back over to switch 1, the non-root bridge, we have an alternate port and a root port. Our alternate port is blocking, our root port is forwarding. The second thing I want to show you is the priority. So as you can see, for both the root and the switch that we're on here, the priority is 32.769. What that is the default priority, 32.768, plus the VLAN that we're on. So if we wanted to make this switch the root, all we would have to do is enter a command that will change the priority for us here. Spanning tree VLAN 1 root, and we're gonna make this one the primary root. So as you can see, you could make it as a primary root or a secondary root. We're gonna go ahead and choose primary. Okay, now when we run the show spanning tree command again, what we should notice is the root MAC address is going to be the same as our MAC address, and our priority should be lower than the default 32.769. So let's try it. Okay, here we go. This bridge is the root. It looked like it worked. We'll look at our MAC addresses. Okay, our switch is the root, and it looks like by entering that command, that dropped the priority for us to 24.577. Now, to take it just a little bit further, let's look at this section down here. So over here we're going to have our interfaces, our roles, and like I told you, the root is going to have all of its ports in a designated state. So once this became the root, those roles changed. Now right here you can tell that Fast Ethernet 29 is set up to go ahead and forward, and Fast Ethernet 31, well, it looks like that was actually in a learning stage when we ran our show spanning tree command. So if we run it again, it should show us what it decided on. Okay, so as you can see, it learned what was going on and it decided to go ahead and switch into a forwarding state. Right here is your cost. 19 is most likely what you're going to see when you're dealing with your Ethernet cables. Now, if you're running a port channel, one thing you're going to notice here is your cost is not going to be 19. It's actually going to be 12. So that's one good thing to keep in mind. But most of the time when you're dealing with Ethernet on modern switches, it's going to be 19 that you're seeing there. Now this number right here is the port priority. And it's actually the port priority not for these ports, 29 and 31. It's actually the port priority that's being broadcast from the ports on the other side, which is switch over to switch 2 here. So actually 10 and 12 are sending those out. And these are the port priorities that 29 and 31 are sending out. So they're all sending out 128. Now, the purpose for those, if you look here, now both sides over here are forwarding, over here on our root bridge. Oh, sorry. Okay, the switch is no longer the root. So, as you can see on our root, both ports are forwarding. This is the root. So, if we jump over here, 10's been chosen as a root, and 11 has been chosen as alternate, which means it's the one that's going to block for now. The reason that is because based on the fact that they're all tied, right? So they're both connecting to the root, and they're both at a priority of 128. The tiebreaker is going to be the number of the port, so 10 beats out 11. So you might want to be able to alter that. You might want to say, I want 10 to go to a blocking state, and I want 11 to be the one that's forwarding. So that's where our port priorities are going to come in. So if we wanted to lower the port priority on gig 11 here, lower than 128, so these actually have to be in multiples of 16, so let's say we set that to 64, right? It would actually turn into the root port, be forwarding. This one would turn to alternate and start blocking. So let's try that. So gig 11, like I said, this is actually the port priority cost being broadcast from the other side. So if we hop over to switch 1 on 31, if we were to set this port to 64 over here, then the other side, 11, should transition states. So let's try that. Oh, sorry, it's fast Ethernet. So we can go anywhere from 16, 32, 48, 64. Let's go with 64 because it's half of 128, just for fun. Okay, so we've entered that. Control Z, show spanning tree. As you can see, 64. No change here, right? But let's take a look and see what happened on the other side. Okay, if you look here, 10 was the root, 11 was the alternate, 10 was forwarding, 11 was blocking. Let's see what it looks like now. Okay, look, so they flipped around. 10 is now blocking, 11 is forwarding. Because the opposite side has now been told to broadcast a lower port priority. So that's how you can make those kind of changes if you want to manipulate what ports are actually in the blocking stage. Okay, so if we even want to go a bit deeper into spanning tree here on our CCNP level, we want to look over here at the type. Now, this right here says P2P, which most likely is what it's always going to say for you. But there is an instance when it will actually say something different here. So let's change the spanning tree mode on here. So spanning tree mode, rapid. What are our options here? Okay. Rapid dash per VLAN spanning tree. Okay. So let's set up switch 1 here in the spanning tree mode of rapid per VLAN spanning tree. And as you can see, it now shows that it's in rapid spanning tree, right? So where previously it said spanning tree protocol IEEE. Now we've set it to rapid spanning tree. So let's hop over to switch 2, right? So this one set to IEEE, so spanning tree mode. Now instead of setting this one to rapid per VLAN spanning tree, I'm just going to set it to per VLAN spanning tree. So we have sort of a mismatch of our modes. Okay. Here's what I wanted to show you. So if we're looking on switch 1, we can see that we're getting a little bit different of an output here. So previously, our type stated P2P. Now, since we set one to rapid spanning tree and one to just non-rapid per VLAN spanning tree, we're getting this output here, peer STP. So that's following our P2P. So if you were to ever see that, you would know why that is. It's because you have one side set to rapid PBST, the other side set to PBST. So it also kind of gives you a rundown on how you can switch those modes. So if we look, right, spanning tree mode, and then whatever mode we want to go for. Okay, so that's a pretty in-depth look at the priorities in spanning tree, the modes in spanning tree, how to change them at least, how to tell if you're on the root bridge, okay, what our roles are, what the status of our port is, just kind of how to interpret the show spanning tree command. All right, thanks.